there are two metrics in there that you're trying to fit. You're trying to fit how, like, the average income in a country versus the happiness. Now, the average income, if we measure in US dollars, is somewhere between $0 and $70,000 for a country, right? The happiness is somewhere between, like, I don't remember, like 0 and 1. So what's the difference between 0 and 1 and 0 and 100? You have 2 orders of magnitude, right? So if you want to take a step of 5 in something that's measured from 0 to 100, that's a relatively small step, right? What happens if you take a step of 5 in something that's measured from 0 to 1? It's not going to be very good, right? You're going to go 0, 5, 0, 5, 0, 5, 0, 5. So we have to scale our data that's going in. So there's different scaling methods, but our goal here, right, is maybe these plots are messed up. I think I need to flip those plots. Our goal is to take something like this and go like that through scaling, right? Because if each one of these rings are kind of like where I'm trying to move, I move much faster through theta 2. So I move much slower through theta 2 than I do for theta 1, right? So those lines are about the same length, the two purple lines I just drew, and the one on the right is only about halfway, and the one on the top is almost all the way. So I need to be able to scale my data to do my measurements. Now, the trick is you got to scale your data, do your gradient descent, and then you got to bring it back out, right? You got to on-scale it on the back out. That's typically where people kind of mess up in the homework. There's two very common ways to do scaling. You can do min-max scaling. It's really nice. X prime, which is just our adjusted number, is x minus x min over x max minus x min. It rescales everything from 0 to 1. Really like things scale from 0 to 1. Makes a lot of sense. What's the problem? It's sensitive to outliers, right? What happens if my data looks like this and I have one outlier? It's just going to scale it like this, right? And so a big chunk of that is going to be empty. Sometimes you want to acknowledge that something is an outlier. If you look at the Ames data set, right, there's a couple houses that are really big and really cheap, and some houses that are quite expensive and not super big. So that's a problem with min-max scaling. Standardization is a good way to do it. You end up with a zero mean unit variance, right? Unit variance is super nice. That means that things are going to be well structured. Zero mean, super nice. You can still get a value of 25, 30, but you know very quickly that it's an outlier and it doesn't squish the rest of your data. You can play around with both of these. In sklearn, it's min-max scalar or standard scalar.